So in the previous examples, we've been talking about logarithms. In example 2, we graphed an exponential function 3 to the x, and we graphed its inverse, or a log base 3 of x. So I want you to notice whatever the base was on the exponential, that will be the base, or the subscript of the logarithm. So in example 3, we are going to start evaluating logarithmic expressions, and we're going to rewrite from exponential to logarithmic form or vice versa, and then solve or evaluate where appropriate. So let's go ahead and take a look at the first line, which is filled in as an example. So on the first line, we are given the exponential form 2 cubed equals 8, which hopefully we can all agree is a true statement. The logarithmic form of that would be 3 equals log base 2 of 8. So let's try to see how all of that fits together. So I am going to box out the base in blue here. And if we look in the logarithmic form, the base is the subscript here. So the base was 2, and here the base ends up in the subscript. Now the exponent, I am going to circle in green. In the exponential form, it was in the exponent, but in the logarithmic form, it is the answer, or the other side of the equal sign. And then the last part of the expression, I'll go ahead and put in a triangle, is the value of the exponential expression, which is 8. And I want you to notice that the value becomes the input to the logarithm. So the translation, the base of the exponential becomes the subscript, the exponent is the answer, and the answer becomes the input to the logarithm. A very important thing about logarithms is logarithms are just a fancy way of saying what is the exponent. So when I read this logarithmic form, what I'm going to think of this is as what is the exponent on 2 that gives an answer of 8. So let me write that out in words. So I'll say it one more time. This means what is the exponent of 2 that gives an answer of 8? Well, of course, we know that the exponent on 2 that gives an answer of 8 is 3. And if we look back at the exponential form, that translates to 2 raised to the power 3 equals 8. So part of logarithms is just training your eye where to look. So if we look at this next one, it's given in logarithmic form. The way I would interpret this is what is the exponent of 4 that gives an answer of 16? Hopefully you recognize that the exponent of 4 that gives an answer of 16 is 2. And the way we would translate to exponential form is we would kind of go backwards. So I would start with the 4 as the base. So that's what I would write over here. On the answer side, that is going to be the exponent. So that's going to go over here as the exponent. And then the answer is what is on the inside. So 4 squared equals 16 is the translation. So the way that I look at logarithms is the base raised to the number on the other side of the equal sign equals what's inside the logarithm. So 4 squared equals 16. Okay, we're going to just keep on practicing translation, because as long as you can translate a logarithm, you can find the answer. And you'll notice I've stopped editing these videos, so there's lots of weird little vocal mistakes. Okay, so here we go. 4 to the y equals x. If it helps you, we can diagram this out again. So 4 is the base. So I'm going to go over here and I'm going to write a log with a base of 4. Okay. The exponent is what goes on the other side. So I'm going to start by saying y equals. And then whatever the answer was, that becomes what is on the inside of the logarithm. So, that should be an x. So y equals log base 4 of x. If I were to translate back, 4 to the y equals x. So again, we're looking at this as the answer to the exponential becomes the input, and then the exponent of the exponential becomes the output. So we're just swapping inputs and outputs. Okay, log base x of 25 equals 2. So I'm thinking of this as what exponent on x gives me 25? Well, we don't know what x is actually, so we're going to translate this as the base to the other side equals 25. So here's my translation. X squared equals 25. And we are going to go ahead and actually solve that. We know that x could equal plus or minus 5. But just like on exponential functions, the base cannot be negative. So remember, this is the base, and the base always has to be greater than 0. So then x equals 5. Okay, one more translation. We are doing 2 to the y equals root 2. So the base raised to the other side equals what's in the logarithm. So 2 to the y equals root 2. And we are going to go ahead and evaluate that. So 2 to the what equals root 2. Hopefully you recognize that the y value is 1/2, because in order to get something inside of a root with the same base, so this is 2 to the something and this is root 2, the equivalent exponential form of a root is a 1/2 power. So the y is 1/2. On the next page, we will be evaluating more logarithms, but the key thing that you need to keep in mind is kind of this diagramming idea that we did here, and also the translation that we did up here. So we're going to write this down at the top of our page. We're going to say b to the y equals x is how we're going to get something out of a logarithm.